Okay, now we are going to talk about measurement. So there's a couple different measurements that we need to look at. The first one being length. Length is simply the straight line distance between 2 points. So we have the straight line distance between 2 points, and it has to be a straight line because think about it, if you're measuring how tall you are, you've got to go from your feet to your head. You wouldn't draw a squiggly line or a circle going around, because then if you're only 5 feet tall, it would look more like you're 7 feet tall, and we know that's not right. So we're going to use something called the SI unit. I know it says SI, but what SI actually stands for is International System of Measurement. So pretty much everywhere in the world uses SI units. The U.S. is one of the very few, if not the only place, I'd have to look that up, that does not use this system of measurement. If we were going to measure something here and the length of it, we would use feet, inches, or a yardstick. But pretty much anywhere else you go in the world, they're going to use meters, or kilometers, millimeters, centimeters. They're going to use something that has meter in it. The tool that you use to measure length is going to be a meter stick or a ruler. Now, I have a meter stick in the classroom, and it's comparable to about a yard, but it's not the exact same. It is different. 1 meter is equal to 100 centimeters. And whenever you use a ruler, you always use the centimeter side, okay? So pay attention to that, because in science class, you always use SI units, never anything else. So you'll have your ruler, and on one side it will have inches, and then the other side it will have centimeters. Inches are larger. So I'm just guesstimating, say these are inches, your centimeters are going to be a little bit smaller. And then within your centimeters, you have something even smaller, and those are millimeters. There are 10 millimeters for every centimeter. So those teeny tiny little lines that go all between the centimeters, those are millimeters. And I know my drawing of a ruler is absolutely horrible, but you can imagine it. And if you can't imagine it, then whenever you get a ruler, just look at it. So always use a centimeter side. Never, ever, ever measure something in inches. Okay. Hopefully you are done writing this down, and we will move on to volume. Okay, so volume, or actually temperature, excuse me. Temperature is the amount of heat given off by an object. So basically, how hot or cold something is. If you're taking your temperature, you're seeing how much heat is in you. If it's a high temperature, then you're probably sick and you shouldn't be at school. So temperature, we have 2 different SI units that you can use, Celsius or Kelvin. Celsius is mainly what we are going to be using. Kelvin is really only used when you get into chemistry and to physics, but I did want to go ahead and expose you to it. Now, you do not need to memorize this formula, but you do need to write that formula down. Okay, we're going to do an activity where you'll have to convert Celsius into Kelvin, but you don't need to memorize that for your test, but do be sure to jot it down in your notes. So just like when you look at a ruler, it has inches on one side and centimeters on the other side. When you look at a thermometer, it's going to have Fahrenheit on one side and Celsius on the other side. So always make sure that you are taking those measurements in Celsius. We do not use Fahrenheit anymore. And just to kind of give you an idea of the difference in them, the freezing point of Fahrenheit is what? It's 32 degrees. And the boiling point, anybody know that? That is going to be 212 degrees Fahrenheit. So Fahrenheit, we say freezing is 32 and boiling is 212. Well, if you really stop to think about it, that's pretty random. Where in the world did they get 32 and how do they get 212? Well, Celsius actually makes a lot more sense. Freezing point is 0 degrees and boiling is 100. I don't know why we don't use this system, but that actually does make a lot more sense to have something freeze at 0 and boil at 100. To give you another idea, if it was 90 degrees Fahrenheit here, then that in Celsius, it would only be 32 degrees. So when you're looking at Celsius, if it's ever in the 20s or 30s, that's actually very warm. even though to us we think of that being more freezing because we have this random number of 32 degrees freezing. Now, you don't ever need to memorize the formula to convert to Celsius and Fahrenheit, because any class you're ever in, they're going to give you that formula, so you don't need to know that. But make sure you always measure in Celsius. Now, let's move on to a brain break. So I want everybody to put their arms straight up into the ceiling, elbows not bent, and you're going to get your right arm and spin it in circles going to the right, and get your left arm and spin it in circles going to the left. So basically you're spinning your arms in 2 different directions. So y'all can pause this video while you have a little brain break. Okay, I hope you enjoyed that brain break. I, for one, am not very good at doing that. I'm very uncoordinated. But let's continue on to mass. Mass is how much matter is in an object. Now, a lot of times students will think of this as weight, but mass and weight are actually 2 different things. Now, you don't need to write this down, but at the bottom I did put a little side note. So again, don't write that down. But the way that mass and weight differ is mass is the same everywhere, because no matter where you go, you still have the same amount of matter within you. Weight, however, will change. If you were to weigh yourself here on the earth, you would weigh differently than you would weigh if you went to Mars or something, or the moon, because weight is dependent on gravity. So if the gravity changes, your weight changes. Mass is the same all the time. The SI unit for mass is grams. So grams is going to be a little bit smaller. Kilogram is going to be comparable to about a pound. So if you were to go to the doctor's office somewhere in a different country, instead of saying how many pounds you weigh, they would actually say how many kilograms you are. So that is mass. Now, maybe you remember this from when you were younger, but in math class, a lot of times they would give you like a little cube, and that was a ones place, a ones block, I guess, and then they'd give you a stick, and that was your tens, and then they'd give you a whole block, and that was your 100s. Then you could add them all together and get your whole number. I'm not going to give you a ones stick and a 100s block and stuff like that, but a triple beam balance, which is one of the tools that you use, it uses the same concept. So you have a 100s block right here, you have a tens place, and then you have a ones right here. So if you were to find the mass of whatever's on this scale, you would add up these numbers. So here you have 300, so it'd be 300 plus 70, because that's what's on the tens place, plus down here, let's just say that's 3.5. So the mass of this object would be 373.5. So pretty simple. And that's really all there is to it. And if you're using an electric scale, then you don't have to add anything up, because it will just tell you what it is in grams. And our last measurement we're going to look at is volume. Volume is simply the amount of space that an object takes up. You are sitting in the room and you take up space. Your chair takes up space. Your desk takes up space. So because it takes up space, therefore it has a volume. And there are 3 units that we use to measure volume: a liter, milliliter, and a centimeter cubed. So centimeter cube is actually going to be used when you're finding the volume of a solid object, such as like a cube or a box. A liter and milliliter is going to be used when you're finding the volume of a liquid. So there's 1,000 milliliters in 1 liter. So if you think about a milliliter being comparable to a few drops, maybe about 10 drops of water from a pipette, if you multiply that amount by 1,000, then you would get 1 liter. So you'll use a graduated cylinder for the liquids, obviously, and a ruler for a solid. And we will go ahead and move on. If you need to pause it to finish it, you can. But next slide. There are 3 methods that we use to measure volume. The first method we're going to talk about is what we use to measure liquids. So something such as water. You use a graduated cylinder. And I'm sure that you all, at some point in your science classes, have seen a graduated cylinder before. But that's it right there. You just pour the water into the graduated cylinder and you read it on the side, kind of like a ruler. But if you are going to find the volume of a regular object, this is something like a block, then you do length times width times height. So, and it doesn't really matter if you're measuring this way versus this way or this way first. Sometimes students will get into a debate about which one is the length and which one is the width. It doesn't matter, because if you remember anything about orders of operations in math, if you're multiplying it, then if you do height times width times length, or width times height times length, or whatever, it doesn't matter. It's going to give you the same answer. So just take those three measurements, put them all together, and then you get your volume. Now, does anybody remember what the formula for area is? Okay, area is length times width. Now, you may need to know that at some point, so just to throw that out there for a little reminder for those of you who forgot all basic math. That is your area, but for volume, it's all three of them. Okay, so now let's think about how would I find the volume of a rock? So if I gave you something like a rock, then what would you do to get the volume? You would do something called irregular displacement. It's also called water displacement or finding the volume of an irregular object. Those are all three names that you may hear it by. So what you do with this is you get a graduated cylinder, you put water in it. Now you have to read your initial volume of water first, okay? So in the example of this picture, what is the initial volume? The initial volume is 10 milliliters. Well, they drop the marble in there, and when they drop the marble in there, the water level goes up to 15. So all you have to do is subtract the difference. So 15 minus 10 equals 5. Okay, so the volume of this marble would be 5 centimeters cubed, or 5 milliliters. You could really write it either way since you're looking at the volume that the water went up. So 5 milliliters. Now, anytime you do this, because you're about to do this in a lab activity, please don't forget to find the initial volume. Some people get so excited they just plop the rock right in the graduated cylinder, and then they can't do the subtraction because they have no idea what the volume was in the first place. So don't get super excited. Make sure that you read the volume level first. Okay. Now, the next thing that I want you to do is draw this within your notes. And this is your graduated cylinder. You don't have to do a beautiful picture of an eyeball, okay? You can do something very basic. Let's see. There's my eye. Isn't it beautiful? Okay, so you just draw an eye, because whenever you read from a graduated cylinder, you need to be eye level. If you are looking down on the graduated cylinder because you're standing or sitting, then the water is going to look like it's at a different number than if you actually bent down to make sure you were reading it correctly. The other thing you do is you read the volume from the bottom of what we call a meniscus. Everybody say meniscus. Okay, meniscus simply means that when you put the water in the graduated cylinder, I'll draw a little cylinder, it's going to dip down. And the reason this happens is because water has a cohesive property, meaning it likes to stick together, but it also is adhesive, meaning it likes to stick to other things. So when you put the water in here, it likes to stick to the side of the glass or the side of the plastic in the cylinder, and that's what makes it do that little curve shape. But you always read from the bottom of the meniscus. So in this picture right here, if we look at the volume, you start at 6, and then you count up, so 6, 6.1, 2, 3. So this is about 6.3 milliliters, okay? If you're looking at the bottom, this other one over here, so you have 30, halfway between 30 and 40 is 35, and this is right over it, so this volume is about 36 milliliters. And you know that because you were drawing from the bottom of the meniscus. And that is all there is as far as our measurements go.